make a standard solution. Standard solutions, what is a standard solution? Well, it's a solution that you accurately know the concentration of by definition. That's all it means. It basically means that if you look at some solution, maybe this coffee, for example, or whatever, I would accurately know the concentration of it. So I would be able to tell you that this is a 1 mole per liter coffee solution, for example. How do you know that standard solution? How do you know how to that concentration? Well, in most cases, it requires you to make it. Okay, and how do you make it? Well, you're going to measure out a solid, a certain amount of solid, and of course, that's going to equal a certain amount, certain moles of that solute, and then we're going to put it into some water to make our molar concentration, or moles per liter, in most cases. It doesn't have to be. But a standard solution, once again, is any solution that you accurately know the concentration of. Okay? You can determine standard solutions by carefully determining the mass of solute to be dissolved in a particular volume of solvent. This is accomplished by preliminary calculations. I'm going to get you guys right now to do this for me right now. So I want you guys to figure out what mass of sodium chlorate must be measured out in order to prepare 100 milliliters of 0.15 molar sodium chlorate. You guys should hopefully be able to do this by now at this stage. Okay? We want to find the mass of sodium chlorate that we need to use to make this concentration and that much of it. So go ahead and do that right now. Okay, so once again, we want to find the mass of sodium chlorate. We know the formula for sodium chlorate. It's up there, so that's kind of give me there for that part. If not, make sure you're able to get that formula. Sodium's 1 plus, chlorate's a 1 minus, so swap and drop. Well, what do we need here? If we want to look for the mass, okay, then I need to know N and big M. Well, you can think about that right now if you want. If I wanted to find the mass of sodium chlorate, I need to know the moles, which I don't know right now. I need to know the molar mass, which I think is 106.44. Okay, 106.44 grams per mole. But I don't know N still. So where am I going to get N from? Well, I have C equals N over V. And if I want to find N, of course, I'm taking C times V. C is 0.15 molar, fine. Or moles per liter, as we say. And V, of course, is 100 milliliters. 100 milliliters, well, I want to make sure that's in liters. So 0.1 liters. Okay, make sure. This formula, remember, you have to remember the units that go with this. So multiplying those two, it's 0.015 moles. Now I know N, so I know N, I know the molar mass, 0.015 moles, and between those two there, I can figure out that this is in fact, I actually forget here, 106.44, 1.5966, or 1.6 grams, significant digits. Okay? 2 significant digits because, of course, 2 here. Okay? So that's how you would make this. You would measure out 1.6 grams of sodium chlorate and basically put it into 100 milliliters, and that would give you that concentration of 0.15 moles per liter. Okay? And I'll show you how to do that in a little bit here. Okay? So that's the first one there. Like I said, how are you going to do this? You're going to use a scale. You've got to weigh stuff out, so you need a scale. We also need something called the volumetric flask. Volumetric flasks are good at one thing and one thing only, and it's measuring a specific volume. Okay, and I'll show you some today here. Standard solutions are always prepared in volumetric flasks. Always, always. Okay? Students typically use a 100 milliliter one. So, this is important. If, you might want to put a little note here, if the question does not say how much volume to use, you assume it's 100 milliliters. Okay? So some questions are not going to say, I want you to make this volume of solution. You will assume 100 milliliters. Okay? Basically, it's going to be 100 unless we tell you otherwise. Okay? But in a lot of questions that you're going to see, It will not tell you a volume in that question, and then sometimes we say, gee, I don't even know where to start. All I have is C. What can I get from C? Well, in that case, if you see a I'm going to show you some today. If you just have C, then you have to remember that V is probably going to be 100 milliliters. That'll get you going on the right path there, okay? This one here says describe. So this is the kind of the first introduction we have into this word here. Describe how you're going to prepare 36.5 ppt solution ammonium nitrate. I put this one here just basically for a little bit of review for ppt, ppm, and percent stuff. That's really what this is for. Let's take a look at this one though, and then I'll show you 4 things that we need to write out for the describing part. And then, like I said, later I'll demonstrate what that actually is going to be when we go to the lab. Okay? So this one here, we'd say 36.5 ppt. What does that mean? 36.5 grams out of 1,000 milliliters, right? Now, how would you prepare that? Well, you take 36.5 grams and you put it into 1,000 milliliters of water. That's what that means, okay? But I'm going to tell you right now, 1,000 milliliters is a liter of water. That's a lot of stuff, okay? In most cases, we don't want to use a liter or 1,000 milliliters. We want to use 100. 100 is a nice number that we can work with. So once again, here we're going to assume that we want to make 100 milliliter of this solution. So how many grams should I use if I'm only going to use 100? Well, you can cross multiply or do whatever you wish, but basically it's going to work out to be 3.65 grams, right? So 1,000 to 100 is a factor of 10, or a tenth as much. So 36.5 down to 3.65, a tenth as much, right? So the equivalent fractions, ppt, ppm, percent. That's all we put in here. How would you describe how to do this? Well, there's 4 steps to go with this, and I'll do these 4 again with you on the next question, and then we will do a demonstration for you here. So first step you're going to do is you're going to weigh out, in this case here, for this particular problem, you'd weigh out 3.65 grams of, I believe it was ammonium nitrate, which looks like that. Okay? So you'd weigh out that solid of whatever compound you need. So that's exactly what you're going to have there. I'll tell you what changes from question to question. The only thing that's going to change is you're going to change this and what compound you're weighing out. Those are the only 2 things that are going to change for this. Okay? And you don't have to have the exact same wording as this up here, but it has to be somewhat close so that I know what you're doing. Okay? You're going to weigh out so many grams of that compound. You are going to dissolve it, into 100 milliliter volumetric flask. This has to be there, 100 milliliter volumetric flask. Okay? We're not weighing it out in a beaker. We're not weighing it out in Erlenmeyer flask or anything like that. It's a volumetric flask. They're very specific. They have specific jobs. Okay? That may change. This 100, it could change. Okay? So in some cases, we may ask you to make 250 milliliters of the solution, or 500, or even maybe in some cases we want to make a liter of it. Okay? For example, when it comes lab time for you guys, I don't make 100 milliliters. That's not enough for 7 groups times 3 classes. That's 21 groups. That's not going to be enough. 100 milliliters, that means you get 5 milliliters each. That's not a lot. Okay? So I make a liter of that, for example. That's when you'd want to use a liter. Okay? So that number may change, but unless the question says otherwise, it's probably going to be 100. Okay? 3, you're going to fill it up. Fill with, now I'm going to put in here for the first one anyway, fill with distilled water to the calibration line. Okay, and I'll show you where that calibration line is. You do want to use distilled water though, because distilled water has basically all the ions taken out of it. Okay, so like if you went to the tap water, for example, and you got some, or if you went to the tap out here, sometimes you can taste the water, can't you? Especially with the taps out here, you can taste that, right? It doesn't taste like water, it tastes like whatever, right? So, you know, when you can taste that, that means there's something in there, obviously, right? So it could be copper, could be a little bit of calcium, magnesium. There's something in there that you can obviously taste, okay? Not saying it's bad for you, but of course we don't want that in with other compounds in there. For example, in this case here, we wouldn't want that in with ammonium and nitrate in there. We just want ammonium nitrate. And if we start mixing other stuff in there, that could potentially be quite bad, okay? So 4, simply put, then you need to mix it up. So you're going to mix well, okay? And if I have enough coffee by that time, I'll show you some dance moves, all right? We'll see. All right, so those are your 4 steps that you're going to write out for these, okay? 3 and 4 aren't going to change. 1 and 2 will change slightly depending on the question, and tomorrow they'll change a little bit again as well, but 3 and 4 will always remain the same, okay? So really you only got to memorize, well, you got to memorize all 4, but really 1 and 2 is the only thing that possibly could change here. We have one more question here. Let's do this one. I'll give you a little second here. I'll give you a little break. You guys work on this one, and then we will go over this one. Okay, so once again, okay, we're going to start with these 2 formulas here. C equals N over V and N equals little m over big M. We want to find how are you going to prepare this. Basically what they're saying is what are we going to weigh out? How much lithium nitrate do we need to weigh out? And how much do we need to put it into to get this concentration of 0.18 molar? So once again, okay, 0.18 molar, that can go right here. That's their concentration or molar concentration. All we know is that I want to make 0.18 molar. This question does not say how much to make, so we have to assume 100 milliliters. And of course, that leaves us with 0.18 moles of solid is how much we will need to use. Okay, well, 0.018 moles of solid with the molar mass of lithium nitrate. By the way, lithium nitrate looks like this, right? 1 plus, nitrate's a 1 minus. So molar mass of that is, somebody have that? I forget what it is now. Sorry, what? 68.95, yeah, that's it. 68.95 grams per mole. And we can find, of course, the magical mass number, which is what? 0.018 times 68.95. So 1.24 grams. Or, I guess in this case, 2 significant digits only, so 1.2 grams. Okay? All right? Good? So, once again, anytime you see this word describe here, we need to write out 4 steps. In other words, basically describe how you would do this. All right? So, on a quiz, things like that, when you see that word describe, we need to make sure we write out some steps on how to do this. Okay? These are pretty basic steps. I'll show you what actually you have to do here. It's a little bit different, but basically it's the same. It's a summary of what you have to do. You need to, in this case, weigh out, of course, 1.2 grams of lithium nitrate. Okay? 2, you're going to dissolve into 100 milliliter volumetric flask. 3, like I said, always going to be the same here. You're going to fill with distilled water to the calibration line. And 4, you're going to mix well. Okay? Mix well. So weigh out 1.2 grams of lithium nitrate. You're going to dissolve that into 100 milliliters of volumetric flask, into 100 milliliters volumetric flask, fill to the calibration line with distilled water, and mix well. Okay? And as long as you have something similar to what you see up here, that's the main thing for that. Okay? So that's what we're going to do for that. All right? Good? Questions? Okay. So how are you actually going to do this when we get to lab time? So what I need you guys to do is, you can do it on the back if you want, I don't care. But listen, we need to do, or on a separate piece of paper is fine as well. But there's going to be two things on how to prepare standard solutions. Today's lesson, and there's another way to do it tomorrow. And we need to keep these in a special spot somewhere, because when it comes to Unit 4, we're going to get you to make two standard solutions and mix them together, and we're going to do a bunch of other stuff with it as well. So it's going to be a good review thing, whatever. And not only do you need it for this lesson, it's going to be very important for this unit, I guess I should say, but it's also going to be down the road. So we need to make sure we can find this at some point in time. And I'll tell you what lesson we're going to do. I'll say, remember in Unit 3, Lesson 4, we talked about 4 and 5, we talked about how to prepare standard solutions. Make sure this stays somewhere close to there, or make sure you put it in a special spot so that you have it for later. Okay? We are going to prepare a standard solution in the lab. Okay? How do you prepare a standard solution in the lab here? Okay? And there's two ways you can do this. We're only going to focus on today, which is basically what we've been doing here. So, how do you make a standard solution in the lab? Now, I'm not saying that this is the only way, but it's the way that makes the most sense. Okay? And I'm sure there's other ways you can do it too. And if it was different circumstances, I probably wouldn't necessarily go through the same steps. But let's do an example here. So we're just going to pick an example here. I happen to have some describe how to prepare a 0.0601 molar solution of copper 2 sulfate. That's what I kind of picked out today for you guys. Copper 2 sulfate pentahydrate. Okay. Describe how to prepare a 0.0601 molar solution of copper 2 sulfate pentahydrate. Okay, so I want you guys to do the first part yourself. Do the math part on this. As always, you need a calculation here. We've got to figure out how much to weigh out, and then I'll show you how to do this over here with the scale and etc. All right, so we need to, once again, right, and use these two formulas here to figure out this. So we're looking for N here, because of course we need to use that with the molar mass. So we got, oh sorry, let me do C times V here, of course. N, we know C. Once again, you need to look at these questions. You may not know V, it may not say, but we assume, of course, 100 milliliters. So we'll put that in there. We want to make a 0.0601 mole per liter solution. Okay, so we have those two things there. We can find 0.00601 moles. There. If I want to figure out the mass, okay, how am I going to actually make this solution? I'm going to take N times big M, and like I said, I already have 0.00601 moles. And the molar mass is what? 249.72? Is that right? I think so. Grams per mole. And when we calculate that out, yeah. Because I multiplied by 0.1. Yeah. When I multiply those two out, I should get, I believe, it's about 1.50 grams. Okay? Yes? Good? So, what is that going to look like when we actually go to do this? Okay? And yes, you could write down 4 steps based on this, and on a quiz, that's what you're going to have to do. Weigh out 1.50 grams of copper 2 sulfate pentahydrate. 2. Dissolve it into 100 milliliter volumetric flask. 3. Filter calibration line. 4. Mix well. What does that actually look like here? So, well, first things first. Okay, you're going to need a scale, obviously electronic scale, to weigh out this solid. Okay, so scale. There's really only 2 buttons you need to know about the scale. If you guys haven't used a lot of scales, we did before, I know a little bit, but you turn it on. Okay, if it's not already on. It usually goes through a warm-up process, so you just got to be patient. If you're the first one to turn it on, be patient, okay? Don't try and weigh stuff right away. It's going to throw things off. So now it's reading zeros, okay? We're going to need, obviously, a copper 2 sulfate pentahydrates right here. Okay, it's a pretty blue. You'll need some distilled water, okay? You need a scoop, in other words, to dig out the solid with, okay? And then you'll need something to weigh it out, because right now, of course, we just have an empty scale here. So, things to weigh out, you can use a weigh boat at times, if you wish. It's like a boat that you weigh. No, not like that. Or, you can use other things to weigh too, like little beakers, for example, okay? And you need a volumetric flask, as always. We're making a standard solution, so you do need a volumetric flask. Volumetric flasks look like this, okay? Volumetric flasks are good at doing one thing and one thing only, and that is measuring out a set volume, okay? There is no other lines on this flask. It tells you right here that this happens to be the 1,000 milliliter or 1 liter one. There is no lines on this volumetric flask except up in the neck part right here. I don't know if you guys can see that, okay? Basically right where my thumb is there, there's a line right above it, okay? Right there, okay? And that means if when you fill it up with water up to that line right there, that's 1,000 milliliters, all right? That's all it does. There's no other lines on here, so that's all it's good for. All right, just like all this one does, and this one happens to be the 250 is the other one I grabbed, so this only does 250. This one only does 100. That's the one we're going to use, 100. And first class didn't get this one. This one is so cute. This one does 10. Okay? Aww, it's like a baby one. Someday it'll grow up to be a bigger one. No, it won't actually, because it's just stuck at 10. It's a glass object, it wouldn't grow. But it is cute. You got to give it that. All right? So it is cute. We got these for free, so we had to take them basically because, well, they're cute and they needed a home. There's like a little puppy. You got to take it, right? You don't have a choice. All right? And they come in small, and of course they would come in bigger ones too. So for industries, you know, you're not going to make a liter of stuff. You're going to make 1,000 liters of stuff. So you're going to have really big volumetric flasks. Okay. So there's wide varieties, but they have specific volumes for each one of those, and they only do that volume. That's all they do. You look at look at this one here. This is a beaker, okay, just a beaker. But this one does 10, 20, 30, and 40, supposedly. I'm going to tell you right now, though, this does 10, 20, 30, 40, not very accurately, because remember what happens when you go to measure volumes is you have to look across and get a meniscus, right? Well, look at how big that opening is. So that's a long way for the water to spread out. The reason volumetric flasks are accurate is because you force the volume into a smaller opening. Yeah, that's ridiculous, obviously. But look, you force it into a smaller neck. So it's more accurate. The skinnier this is, the more precise you can be, right? And I'll actually show you that tomorrow when we do the other standard solution measurement. You're going to see a really skinny, what we call like a kind of a straw thing, pipette it's called, and it forces it into a very skinny spot, and it's very accurate. Okay, so this is going to be pretty accurate here. All right, this, if I had to measure out 40 milliliters of this, this is probably not very accurate. In fact, it tells you right on there, plus or minus 5%. Okay, well, 5% of 40 is like 2 milliliters. That's a lot. Okay, a lot of difference. That's the difference between 38 and 42, basically. So a range of 4. That's lots. Okay. So we're going to use this one here. Okay. But here's the deal. Look, we need to get solid, 1.5 grams of solid into that opening there, without spilling anything. Because if we spill even a little bit, if we don't put 1.50 grams of solid in, let's say we only get 1.4 grams in, well then guess what? We don't have this many moles. And if we don't have that many moles, we don't have this concentration. We have less. Okay? So it's very, very important that we get all the solid into here. So to do that, you have two options. Okay? You can use a weigh boat and put it on here, And by the way, the other button that you would want to use here is the same button. It's on, off, or 0. If you hit the 0 button, it's like that weigh boat isn't even there. And then you can measure out 1.50 grams. And that's fine. You can do that. But now you got to get that solid into here. Okay? That could be tricky. And usually what happens is you fold it up like so to make it more into a boat. And then you kind of pour it into there. If you think you can do that accurately, good for you. Okay? You might be able to. You know what? Would I use this with perhaps maybe this one? Probably, because look at that opening. It's fairly big, right? I could probably do that, hopefully. Having said that, there's still something else you need to do with that. Okay? But the other thing that works really well is sometimes a little beaker. And that's usually what we use. We use a little beaker. And we put that on there. And I know you can't all see. We put that on there and we 0 it. Okay, so it's like it's not even there. And we measure out our 1.50 grams. And I'll show you why we use the beaker here right away. So, how much is 1.50 grams of copper 2 sulfate pentahydrate? What does it look like? Is it that much? Basically, just to the end of the scoop. Is it like that much? I don't know. That's the thing. And you probably don't know either. And every, of course, compounds weigh different amounts. So if you had a really heavy one like sugar, you need probably less on the scoop than you would of lithium nitrate, which only weighs 68. Okay? So it's hard to say. So here's what you're going to do. You're going to take a little bit and you're going to dump it in. Notice, take this, put it right over top of the beaker and dump it in. Okay? And figure out, kind of see how much that is, engaged from there, how much you need to use. Okay? Now listen, if you, let's get rid of that for a second. If you, that's what you kind of want to do. I see this all the time. We're going to do a lab at the beginning of Unit 4, and it's got green stuff. And we try and do this. We take a bunch of this, and then we try to get it over to here. It's like this magical transformation from here all the way over to here, and then guess what? Now what? And then you try to pour it in, and guess what happens? There's green stuff everywhere, okay? Except in the beaker. It's on the scale, it's on the black, you can totally tell because it's black countertops in there. It's all over, you know, there's green stuff everywhere. Well, we don't like that, okay? Because then someone's got to clean it up, which is me. And secondly, you're wasting a bunch of stuff. Okay, and it's not very precise or accurate. So grab the bottle. If you're not happy about, you know, just leave it on there, and get it over right over top here, and dump some in. Okay, we're at 0.6 grams now, so we're roughly about halfway. And then you're going to keep going until you get to 1.50. Okay, that's 1.50 exactly. I hit it right on the nose. If you go over, which I did not, and you have no way of knowing, if you go over, unfortunately, you probably have to throw it out. Okay, so you would actually have to probably take this and come see me, and I'll probably put it in the bucket or whatever, or you may, if it's okay to go in the garbage, we'll throw it in the garbage. Because what happens is, before you start this, of course, it should be clean. Everything should be clean, but I can't take the risk that this is all clean and we can pour it just right back in there. Because if you pour something that's not copper 2 sulfate pentahydrate back into here, oh, we're going to have problems. Okay, and this whole jar is going to be ruined because of maybe 0.1 grams over kind of thing, and we can't take that risk. Okay, so you're going to have to let me know. We're probably going to have to toss it out, and probably in the bucket, probably, and then we'll deal with it later. So if you do go over, okay, that's what you're going to have to do. Okay, now we're going to take this and we're going to get this into here. Now you might say, well, geez, Mr. Bachek, I think the other one probably would have been, the boat would have been better, because look, I got to get that into there, right? Well, here's the thing. You're going to be making a water solution anyway, right? I mean, the goal is to make a solution. We got the solute, we need the solvent. You're going to mix the two together to get 0.0601 molar solution. Well, mix them together now. Dilute it, right? Or not dilute it, but make it a solution. So here we go. It's going to be a pretty blue for you today. This solution, I picked blue for you Stampeder fans today, because I'm sure that's what you're feeling, a little blue, after the kicking you got on the weekend. Go Riders. So, you're going to do that once. Okay, notice I still got stuff in here. Obviously, that's a problem. I don't want it in here. So, you do it again. Okay, we're going to put some more water in here. We're going to dissolve, step 2, dissolve into a 100 milliliter volumetric flask. Okay, you can mix it up a little bit. Careful, don't spill any. Okay, and we're going to pour that into there. Oops, don't spill any. Okay, and you might say, geez, how long is this going to take? Well, as many times as it takes. But remember, this is 40 milliliters at a time, roughly. Well, it's actually 50, but 40 is the marking on here. If you do this, let's say you do 50, let's say you do this twice, full up, well, that's 100, and you're done. Okay? So you have to be careful. If you have a trustworthy partner, this is what I would suggest. Get someone to hold this for you. I would not recommend you doing this by yourself here. And get someone to spray in some water here, distilled water. Okay. Feel free to copy anything down that you need to. And make sure you get all that solid out of there. Okay, and when do you have it all out? Well, when you don't see any more, then I would do another 2. Like so, I'd rinse this out again, right around the top here, get everything to the bottom, and pour that one in. Okay, do it again. Make sure you get it all the way around. Oops. And pour it in. Okay, you have to make sure you get all that solid into here. And if you spill any, then I'd probably suggest you just start over. Okay, there's no fixing that. There's nothing you can do, because you have no idea how much solid left or how much water or anything like that. So, and you're going to fill it up to the calibration line. Okay, so here we go. Now, the only thing about the calibration line is this. Yeah. I need a little more water in here. You could just take it off and pour it, but I'm trying to deal with it later. Okay, so you're going to fill it up to the calibration line. Once again, we'll talk about that in a second. I left it a little bit short of the calibration line. I'm going to cover it with a stopper. Make sure it snaps on there good. Oh, that's a good one. And if it turns, if you snap that lid on and it does this, and you can turn it, it's going to leak. I'll tell you right now, aka first period. Okay, so try not. If you can spin it like this, it's not tight. Okay, and no matter what you do, something's going to leak out. Okay, and I knew that, but I just had to. I didn't have a choice, because some of them fit really well, some don't. It just luck of the draw kind of thing. This one fits really well, so that's good. You can shake it up right now, so if you want to do a little dancing. Domo arigato, Mr. Lawnmower or tractor. No, sprinkler. I know these. I know. I invented all of them. Lawnmower, right? Shopping cart, right? Just be careful when you're doing this. Make sure your thumb's on top, yes, so that it doesn't go off, especially if it's the acid one, right? That's bad. I did sprinkler. Oh, truck driver, also known as the tractor. What other ones we got? Yeah, you guys don't know, because you don't. No. Those aren't options, and I'm not doing that. Okay, so you mix it up. Okay, just shake it up a little bit. Okay, arigato. Shake it up. Give it a few seconds and see what drains down to the bottom, and then kind of see where you are for your calibration line again. Go back, and you're going to have to fill it up a little bit more probably. Just keep in mind that when you do this, okay, water's still coming out of here and still draining down as you're watching it go. So when you stop, water's still going to come out and down, and you're going to overshoot it, okay? Because it takes a little while for the water to get down. Second thing is this. When you go to fill it up to the calibration line, it needs to look like this. There's your line there. You want the water to sit on there, right? The meniscus, right? So you want that kind of thing there, right? The bubble to sit on that line. When you look, you probably should put this on a counter on the lab bench and then get down and look at it straight across, okay, to see where it's at. Or if you really want to hold it, that's fine. I would not recommend that. If you look from the top, you see two lines. If you look from the bottom, you'll see two lines. If you look at it completely level, you'll see one line straight across. That's where you want to look, right? And you want to fill it up so that, okay, so see there's water up there, oops. And you want to fill it up so you see one line straight across and that bubble is sitting on top of it, okay? That's when you have it at eye level, okay? Perfectly level, etc. You're going to cap it up again here one more time. Just shake it up a little bit more again, and then you can let it sit. It's probably good, but that's how you make that standard solution, okay? So, okay? Standard solutions. So, a couple things you need to write down probably, because I noticed you guys didn't write anything down. Make sure, okay? It's up to you what you want to use, but I use a 50 milliliter beaker, okay? You're going to put it on the scale, and you're going to tare it, basically put it back to 0, okay? So 50 milliliter beaker works fine. If you want to use a weigh boat, that's your choice. Listen, if you're going to use a weigh boat, you got to do the same stuff. You're going to have it in here. You're going to pour it into here, into your volumetric flask. Okay, so you're pouring it in. That's fine. Do you think all the solid got off of here into here? Probably not. You're going to have to get someone with a distilled water bottle to spray some water carefully to make sure all the solid gets rinsed into here, okay? That solid has to all make itself into the volumetric flask. Why don't you just weigh it in here then, for example? Why don't you just put that on and weigh it in there? Well, that's fine if you get exactly 1.50. But if you go a little bit over, there's nothing you can do to get that stuff out. Nothing. Okay? Whereas if you go a little bit over on this, you can scoop out a few grains, put them in the garbage or in the bucket, and still use that. Okay? But you're not going to get anything out of that. Okay? And it's going to make a mess as well. Okay? So, you're going to weigh that out. Like I said, weigh boat or 50 milliliter beaker, I don't care. Up to you. But then you need to transfer that solid into the volumetric flask. You need to rinse it with distilled water. Make sure it all gets into there. Okay? I would say fill it up with water to about the calibration line. Fill it up with water to about the calibration line. It has to be distilled water. So, by the way, the distilled water is by the sink in a big white tub, and I always point that out for you if you need to use it, okay? Not tap water, okay? There'll be times when that's acceptable to use, but not for making solutions. So fill it up to about the calibration line, cover it, shake it up, let it rest for a few seconds, a few minutes maybe, let it settle down to the bottom, and then fill it up to the calibration line again. Okay, fill it up to the exact calibration line, cap it, mix it up again, and you should be good. Okay? So those are kind of the steps that you want to follow for that. Okay?